Hi, in this video I will talk about class planning and its powerful features. Class planning is an advanced planning and scheduling software. We offer you a very powerful and easy to use solution in planning for manufacturing companies. We have many features and flexible solutions for your planning problems. Class planning can optimize your production plan under many constraints, from material-driven planning to tools and size optimization, bottleneck management to labor planning, and complex problems can be solved with class planning. You can also manage the capacities of all your plants separately and schedule synchronization between them. By the way, integration to other software in company is easy in class planning with APIs, macros, and wizard. Now, let's look at the main subjects of the problem. In advanced planning, we have several main subjects to handle. These are capacities, resources, integration, bottlenecks, and of course, optimization. How we categorize problem in class planning? To make it easy to solve, we separate problem two parts as plant definition and APS session. So, what is plant definition? The plant consists of capacity, resources, master data, alternative machine and labor transition metrics, sequence-dependent setup settings, job and resource relation rules, job color rules, job priority coefficients, and integrations. Integrations can be easily done with APIs, macros, or wizards. In plant planning, you can define many plants, and also each plant can be integrated with each other. And what is APS session? The APS session optimizes within the scope of plant capacity, bottleneck, scenarios, and constraints. After the plant planning integration is completed, all you need to do is press a few buttons and automate the process. In APS session, you can make any changes in overtime definitions, job priority coefficient, max runtime, labor effort coefficient, work effort compression, and tolerance. You can try different scenarios and choose the most accurate planning scenario by comparing the optimization results. Now, let's check how to define plots in class planning. We go through APS menu and then definitions, plant definitions. This is our sample plant definition. Plant-related integration connections can be defined in these areas. As you can see, job list integrations, materials, tools, dies, and stock integrations, labor and machine maintenance schedule integrations, and last, bottleneck integrations. Integrations can be easily defined via APIs, macros, or wizard. The work centers in the plan defined in this tab. Alternative transaction metrics and sequence-dependent setup settings is defined in this tab. An unlimited number of rules can be defined for our plant. You can go the inner tab with right-clicking the row and then choosing Open App main. As you can see, CNC1 and CNC2 work centers are alternative to each other. A job done in CNC1 is done 50% slower than in CNC2. As can be seen, this definition made by in this document. Rules between jobs and resources can be defined in this tab. And also, you can define color of jobs here. Priority assignment settings in job ordering can be made in this tab. In our plan,
Order delivery date is specified as 60% and setup time minimization is specified as 40% priority level. These values are default values and can be easily changed in APS session. At last, scheduling settings. Detailed settings regarding the schedule of the plan can be made from this tab. Now, let's check how to define APS session. First of all, we need to take a new document for our session. After, we need to choose our plans. Now, we are ready to define our planning horizon. First, we choose our first shift. After that, we define our starting date and then our ending shift. Now, we define our planning horizon. If we have any non-working times, this might be our spatial non-working time, or for our machines, or for our labors. For example, let's define a non-working time, one of our machines. We choose date of non-working. Now we are ready to calculate our capacity. After capacity calculation, you can see your schedule here. As you can see, there is a stop for our first machine. Now we are ready to optimize our jobs. First of all, if we have a bottleneck set up in our plan, we can fix our bottleneck jobs in this button. After, we can refresh our jobs here. Now, all available jobs are listed. If there is already started jobs, we can fix them here. After we choose jobs to optimize, you can see here details of resource usage. This is a generally used resources. In here, we can select planning direction. We can optimize our jobs forward or backward. With pressing optimize button, we started our optimization. After optimization done, we see our jobs listed in Gantt chart. You can check your jobs with right-clicking it and filtering. You can see the whole jobs and operations. You can see any detail of job by hovering your mouse on it. Also, there is extra information with our job list here, assigned works. You can see all assigned jobs in this list. Also, you can see the statistics of product level. Here, you can see this job is late for 3 days. You can see statistics of the optimization in the statistics tabs. Here, there is all information about your optimization, your max span time, your plan starting date, and ending date. Also, there is a extra information about setup times. Now we are ready to optimize. You can get predefined reports from print icon. There are several reports. You can get them by double-clicking it. For example, this is general capacity report of the resources. Or you can get plan summary. If you want to create new report, you can use BI menu. You can get